Today we're going to be answering problems involving parabola in conic sections. Now we need to know that there are two formulas that we need to use when we're working with a parabola in a conic section. This parabola or this formula is what we use if the parabola is opening upwards or downwards. And the second parabola is the formula that we use when the parabola is opening either to the right or to the left. Now h and k in our parabola will be the value of our vertex. So these are the basic information that you need to know to be able to answer problems number 1 up until problem number 4. So let's go ahead and answer problem number 1. So for problem number 1, we need to find the standard and the general equation of the parabola given the minimum point and a point passing through the parabola at 2,8. In conic sections, it's important or it's easier to analyze or answer problems involving a conic section if we're using a graphing paper. So for today, we're going to be using a graphing paper to solve problems 1, 2, 3, and 4. So for problem number 1, let's go ahead and write the information that is given to us. And we are only given the minimum point, which is at -2 and 6, and passing through the point 2 and 8. Now, if we're going to sketch the given information in our graphing paper, we'll be able to visualize how the parabola is opening. So in this case, we have the minimum point, which is at -2, 6, -2, and 6. And -2, 6 is the minimum point, which is in a parabola, the minimum point is the vertex of our parabola. So it's safe to say that this is also the vertex of the given parabola. And the parabola is passing through the point 2 and 8. So 1, 2, and 8. This is 6, 7, 8. So our parabola is indeed opening upwards, and it's passing through that point. And since we know that the parabola is opening upwards, from the two formula that we have, we know that we're going to be using x minus h squared equals 4py minus k. So let's go ahead and write out the formula that we're going to use. And in our vertex, we know that this is our h and this is our k value. So to find and solve for the equation, we need to find the value of p. And to solve for p, all we have to do is replace h and k and x and y with the value of the point that we are using in the problem. So x is equal to 2 minus h, which is -2, for p, y is 8 minus 6. And by simplifying our equation, we'll have 2 plus 2 squared. For p, 8 minus 6 is 2. So we'll end up with 4 squared equal to 8p, and 16 is equal to 8p. So from here, we'll be able to find the value of p, which is 2, because 16 divided by 8 is 2. So p is equal to 2. And you know that your p is positive because the parabola is opening upwards. Now, to answer the question, which is to find the standard and the general equation of the parabola, we're going to use the equation again, x minus h squared equals 4p y minus k. And this time, we are replacing h, p, and k. So we can write the general or the standard equation of the parabola. So we'll have x minus negative 2. P is 2 times y minus k, which is 6, which is x plus 2 equals 8y minus 6. And this is the standard form of our parabola. Now, to find the general form of the parabola, all we have to do is to simplify or equate our standard form to 0. And to do that, we're going to expand x plus 2 squared, and x plus 2 squared is x squared plus 4x plus 4 equals 8y minus 8 times 6 is equal to 48. So by equating this to 0, we'll be able to solve for the general equation of the parabola. So minus 8y and plus 48 on both sides, we'll have negative 8y plus 48 equals 0. And by combining like terms, we will combine 4 and 48, giving us x squared plus 4x minus 8y plus 52 equals 0. And this is our general form. And if you need to find the other parts of the vertex of the parabola, which is the focus and the directrix, the focus is 8 units, because this is our p-value, is 8 units going up from the vertex. So if this is 6, 6 plus 8 units is going to be equal to 14. So our focus will be at negative 2, and the y value is at 14. And our directrix will be 8 units going on the opposite direction. So if this is 6, 6 minus 8 is negative 2. So this will be our directrix. And the directrix passes through the line y equals negative 2. So our directrix is y equals negative 2. So this is our complete analysis for problem number 1, given the minimum and the point passing through the parabola. Let's go ahead and sketch the graph of the given information. Vertex at 3, 2. 1, 2, 3. 1, 2. This is our vertex. Focus at 4, 2. 1, 2, 3, 4. 2. So this is our f. So we know that the parabola is opening to the right. And now that we know how it opens, using our formula, we know that we're using the second formula, which is y minus k squared equals 4px minus h. So let's go ahead and write out the formula that we're using. So from here, h and k is our vertex. So we will replace h and k. And for p, we're also going to replace it because P is simply the distance from the vertex to the focus. And from the vertex to the focus, it's only one unit going to the right. So it's positive 1. So P is equal to positive 1. And by direct substitution, we have y minus k, which is 2. 4 times 1 times x minus h, which is 3. Now we have the standard form of the parabola. And the general form of the parabola by using algebra is y minus 2 squared is y squared minus 4y plus 2 equals 4x minus 12. And by equating it to 0, we'll have y squared minus 4y plus 2. So minus 4x plus 12. We'll have y squared minus 4y minus 4x, and 2 plus 12 is 14. And the last part of the parabola that we can find is the directrix, which is 1 unit away from the vertex. So this is where the directrix is. And it passes through x equals 2. So the directrix is at x equal to 2. And this is our analysis for problem number 2. Now for problem number 3, we are now given the focus, directrix at x equal to 9. Just like what we did on the previous examples, we're going to sketch the graph of the given information. We have focus at 3, 5. So the given information for problem number 2, we have number 3, we have focus at 3, 5, and directrix at x equal to 9. Just like from the previous example, we're going to sketch the given information. Focus at 3, 5. Directrix at x equal to 9. And we know that the directrix is a line. And with this given information, if we know our parabola, we know that the distance between the focus and the directrix is, or the midpoint of the focus and the directrix will be the vertex of our parabola. So by just counting the number of units away from the focus to the directrix, we'll be able to locate our vertex, which is at 6. So our vertex, which we found, is at 6 and positive 5. And we know that the parabola is opening to the left. And if it's opening to the left, once again, the formula that we're going to be using will be the second formula. So we will have y minus k for p x minus h, where h and k is our vertex. Now to find the value of p, the p is the distance from the vertex to the focus, and since it's moving to the left, we have 1, 2, 3 units to the left, so p is negative 3. So just like on our previous example, we will replace k, p, and h. So our formula will now be y minus k, which is 5, equals 4 times negative 3, x minus h, which is 6. So by algebra, we'll have y minus 5 squared equal to negative 12 x minus 6. And this is our standard form. And for the general form, we will expand y minus 5, y squared minus 10y plus 25. Distribute negative 12. 12 times 6 is 72, positive. And by equating it to 0, we'll have y squared minus 10y plus 25 plus 12x minus 72 equal to 0. And by algebra, y squared minus 10y plus 12x, negative 72 plus 25 is negative 47. And this is our general formula or general form of our parabola. And for our last problem for today, we have the vertex at 0, 0 and directrix at x equal to 3. And by graphing our parabola, vertex at 0, 0, so right here at the center, directrix at x equal to 3, 1, 2, 3. So this is our wall. And the focus is opposite the directrix, so 1, 2, 3, negative 3. So f is at negative 3 and 0. So from our formula, since the parabola is opening to the left, we will use y minus k squared equals 4p x minus h, where k, p, and h will be replaced by the vertex and the distance from the vertex to the focus, which is negative 3. So we'll have y minus 0, 4 times negative 3, x minus 0. So we'll have y squared equals negative 12x. This is our standard form, and the general form is pretty simple because we have y squared equals negative 12x plus 12x on both sides. And this is the general form of our parabola.